In this video, we're going to be discussing the pros and cons of nuclear chemistry and other random facts about nuclear chemistry. So, some of the pros of nuclear chemistry include uses in the world of medicine. So we can use nuclear chemistry for various medical reasons. So one way they use this is making nuclear radioactive dyes that they can inject into your bloodstream to look at the blood flow through certain valves of your heart or vessels. They can make a radioactive drink that you can ingest, and then they can get a better image of your digestive system, and as they watch the drink pass through your digestive system. And you're probably aware that you can use nuclear radiation in cancer treatment. So if you have cancer that's metastasized in the body, one of the ways that they kill the cells is by shooting radiation at it to stop them from dividing. Another pro of nuclear chemistry is radioactive dating. So like we saw with half-life, we can very accurately judge time based on the decay of these isotopes. So if you want to learn more about evolutionary history or things like dating fossils or even ancient artifacts, you can use half-life decay to come up with a time frame for when that fossil, that animal, or that artifact was from. We can also use nuclear chemistry for industrial measurements. So back in chapter 3, we talked about how some of the common measurements we use in the metric and standard system are based off of arbitrary things, like the meter was a metal bar. It's actually no longer used anymore. Nowadays they use industrial measurements can be based off of things like the speed of nuclear radiation or how far a particle moves in a given amount of seconds. Time is based on the decay of a radioactive element. And then the reason they pick these things is because they're so steady and unchanging that they're more accurate. We can also use nuclear chemistry for power. There's a lot of controversy over this because of the nuclear accidents that have happened in the past. But nuclear power is actually a cheap, easy, and if taken care of properly, a relatively safe way of creating the energy that the planet needs. We can also use nuclear chemistry to detect diseases. Like I said, you can detect problems with the cardiovascular system by watching these dyes move through the blood vessels of the heart, and you can tell whether someone is having certain heart-related diseases and things like that. Some of the cons. So obviously nuclear chemistry is radioactive, and as much as we talked about how it can be used to treat cancer, it's also a cause of cancer. If your cells are exposed to too much radiation, the energy from the radiation can punch holes in your DNA, and if your DNA makes mistakes in repairing itself, that can lead to cancer. So too much exposure to nuclear radiation is a definite cause of cancer, and we've seen this with some of the nuclear power plant accidents that have happened. So a huge rise in cancer. Also, another con of nuclear chemistry is long-term storage. So we talked about how nuclear power is a cheap, easy way of making energy, but one of the problems of that is the nuclear byproducts of the decay are very long-lived. They have very long half-lives. So we need to find a place that we can keep this dangerous material for many, many years. So nobody is going to raise their hand and say, I want the nuclear waste in my state or my town. So there's a lot of controversy over where this nuclear waste is going to be stored and how it's going to be protected in the long term. We also talked about nuclear accidents. That's a definite con of nuclear chemistry. If a nuclear power plant melts down, it can be catastrophic in what it does to the ecosystem and the people living around it. So there are other need-to-know facts about nuclear chemistry that I don't know why, but for some reason the New York State Regents wants you to know. So these are often one of the last questions on part A of the multiple choice, and there's no way around this other than just knowing these facts. And I don't know why they want you to memorize this stuff, but because it's on the Regents, I think we should prepare for it. So technetium-99 is a particular isotope that is used in treating brain tumors. So a lot of drugs, a lot of chemicals have problems crossing from the blood into your brain. So there's this thing called the blood-brain barrier. And if you have a brain tumor, technetium-99 can actually get out of your blood and into your brain. So it's a very useful isotope for treating brain tumors. Next, we have iodine-131, so that is used for thyroid disorders. So iodine is an element that naturally goes to your thyroid. So if you have thyroid cancer and you inject iodine-131 into the bloodstream, it will naturally go to the source of your thyroid where you need it to treat the disease. Next, we have radium-226 and cobalt-60. These are your general standard use cancer therapy drugs for things like radiation treatment. And then we have two more, uranium-238 and carbon-14. These are used for dating fossils or ancient artifacts. So they have drastically different half-lives. Uranium-238, I don't know what it is off the top of my head, but it's very long. So you use something like uranium-238 for really, really ancient life, like some of the earliest possible evidence of life on the planet. You'd want to use something with an old half-life because it's still going to have some radioactiveness left when you're testing it, hundreds of thousands of years later. Now, carbon-14 has by comparison, a relatively short half-life of a little under 6,000 years. So if you were trying to date one of the oldest known life forms with carbon-14, after hundreds of thousands of years, there's not going to be any carbon-14 left. So that would be a poor choice. If you wanted to date an artifact that you think went back to, like, say, around biblical times, you could use carbon-14 because it's closer to the age, its half-life is closer to the age of your sample, and you'll still have some carbon-14 left. But if you wanted to test one of the earliest known evidences of life on this planet, and you looked at the carbon-14, there'd be none left because the vast, vast majority of it is going to be decayed away after that much time has gone by. So these are the ones that are commonly asked about on the Regents. Again, there's no way around this other than just kind of memorizing it and studying them. So let's wrap things up here. You are expected to know or be able to discuss some of the pros and cons of nuclear chemistry. You don't necessarily need to know the entire list that we talked about, but you should have some of these pros and cons in your back pocket to talk about if the question arises. Also, you're expected to know uses of some of the common radioisotopes that we discussed. There's no way around this other than memorization, so I would suggest making flashcards and studying them.